Hi everyone, I am Onat, and here I will present cycle-consistent adversarial transformers for unpaired MR image translation. Multi-contrast magnetic resonance imaging is a key technology that is often underutilized due to costs associated with multiple scans. Thus, the ability to translate available source contrast to an acquired target contrast has practical implications. Learning-based translation models are commonly trained on spatially registered paired data using pixel-wise error terms, yet it is often challenging to compile large data sets of paired images, which raises interest in methods that can learn from unpaired data. State-of-the-art methods for unpaired image translation are pervasively based on cycle-consistent adversarial architectures with convolutional neural network backbones. However, convolutional networks with compact filters shared across the entire image exhibit a strong bias towards feature locality and spatial invariance. This inductive bias hampers the learning of long-range spatial dependencies, which can be critical for medical image translation. Here, in this study, we proposed a novel deep learning model called residual vision transformers, or ResVid, which is a synergistic combination of global context captured by transformers, localization power of CNNs, and details offered by adversarial learning. Discriminator of ResVid is designated as a patch-can discriminator, whereas the generator follows an encoder-decoder pipeline with a central information bottleneck to distill task-critical information. Here you can see the structure of the proposed art block, which comprises a transformer module that has a residual connection to effectively fuse global and local features extracted by attention-based and convolution-based operators. After the concatenation, a channel compression is applied to synergistically combine these two local and globally context features, and after that, a residual convolutional network is applied to further distill structural and critical task information. We compared cycle consistent ResVid with 5 different competing models, including CNN-based and self-attention GANs, and any recent transformer-based architecture, and note that all models are trained in a cycle consistent and adversarial setup for a fair comparison. In terms of KSNR and SSIM metrics, ResVid offers a performance boost of 2.54 dB KSNR and 1.73% SSIM on average across tasks and competing models. ResVid also reliably captures and depicts pathology in patients, in contrast to the other methods with their inaccurate depictions. To conclude, ResVid aggregates convolutional and transformer features to preserve locality and context at the same time, and it is the first adversarial transformer model for MRI translation with a transformer-based generator. It outperforms state-of-the-art convolutional and self-attention-based GANs, as well as TransUnit, and it's a promising candidate for medical imaging tasks that require contextual sensitivity. Here is the link for reproducing ResVid experiments, and thank you for listening to me.